Hi there. Welcome to the Elm Double Header. Is that what we're selling this as? Yes. My name is Daniel Haveshouse. I'm a Java developer pretending to be an Elm developer. So I'm neither qualified in Elm nor functional programming, but here I am just the same, advocating for Elm. I don't know if any of you are familiar, well, at least one of you is familiar with Elm. Why would you want to use this newfangled language? Well, it's a beautiful thing. It's developer friendly. It sells itself as a delightful language for reliable web programming, and I think it lives up to that. It really is nice to use. It's very pleasant, very helpful, and it's fast. Here are speed comparisons. There are a few versions out of date on Elm. Well, no, just one version out of date on Elm. I can't say on the other ones, but smaller, better. Elm is faster. Yay! Okay. Don't look too closely. So Elm brings functional programming to the web. And functional programming. Sorry. These are the topics I'm going to discuss today. I should look at my slides before I begin. I'm going to talk about functional programming. I'm going to talk about how Elm got functional programming right for the purposes of web development. I'm going to talk about the architecture that has developed as Elm grew and why it works well. And I'm going to try a little live coding, because what could go wrong? So Elm has a history in functional programming rooted back into the lambda calculus and Lisp, because I love parentheses. I actually do. ML and its type inference has been brought into Elm to great effect. And of course, Haskell is what the Elm compiler is written in. And I have to say the obligatory word monad here, and that's the last you'll hear that. So, functional programming I'm going to define for today as something that works with a mutable state. So once you've created something, it stays the same. If you want a new one, you make a new one, you don't change it. There are pure functions, so there are no side effects, and they don't rely on state outside of what is handed into them. And it works with higher order functions. So this means that the functions in Elm can return other functions, and they can take functions as arguments. Other aspects of this functional programming is the composition. You can chain functions together to build up things, or maps and reduces and wonderful things like that. And currying. So if you have a function of multiple arguments, you can give it the first argument and get a function of one fewer arguments. And all of the Elm functions curry automatically. So if you look at a definition of a function in Elm, and we will in a few moments, you will see the argument, arrow, argument, and it just all automatically currying, producing more functions. So what does Elm generate? What does Elm get you if you were to use it? It is a web development language, so it produces JavaScript, it produces HTML, and of course CSS. What does Elm not generate? No. So Elm is you're never going to see this again. You cannot read property X of undefined because there is no undefined. Just maybe. Now here's the first bit of actual Elm code. This is a type definition. It defines the maybe type. This is part of the language definition. And a maybe can be either it's just something or nothing at all. And the something is in lowercase, meaning it's parameterized type here, so that the just comes in with whatever you give it, and something gets replaced by the argument. Is that clear enough? We have a question section later. So the Elm architecture that I mentioned before. This is the structure by which programs are written And it developed as the Elm language grew, and they recognized that each time they wrote programs, it kind of had the same format and the same structure. And the basic pattern is two functions. You've got an update function, given a message and a model, it updates it and produces a new model. And a view can process that model and generate HTML, which in turn can generate messages if you interact with the HTML. And the Elm runtime handles the magic in between. So you define the three things at the top. You define a model, which is the structure. You define those two functions, update and view, and you put them all into a beginner program. And you produce a program. There you go. As I mentioned, the function has that arrow pattern. Yeah, there I mentioned it again. So here's a very simple model. You can simply define the type as an integer. Here's a more complex model. You've got a record here that has values and other structures, references to user that you define somewhere else, and a game board. And as we saw here, the update is driven by a message. That message is a type that you define, and you might define it as something like this: increment and decrement. Just a series of messages. They can be more complex, they can have payloads, but here's a simple pattern for it. This and this are taken directly out of the architecture demo application that we will see in a few moments. And then the view, oh, here it is, from Evan. Evan Jablicki is the creator of Elm. And this is the view from that tutorial. So here we see the HTML in Elm. And HTML, again, it's all functions. It's all Elm. It's all strongly typed. Here we have a definition of view, and we have a type that, pay attention to that. You have an optional type definition above the function, and then the function itself. So every view takes a model and generates HTML and messages. So the type of the input is a model, and here's the argument below. And then the definition of the function calls other functions. So div is a function that takes a list of attributes and a list of children. And those children are other functions. Button takes a list of attributes and a list of children. Text is a function that just takes some text and produces a text object in HTML. These are strongly typed. It's very hard to make an error that doesn't get caught at compile time. It's not hard to make an error, I'll tell you that. But we have a very helpful compiler now. And here are increment and decrement, the messages that we saw defined above. And we pass them as arguments to these existing functions on click. And then the view will produce HTML that will produce a button that, when clicked, will generate that message. Again, in the function, in the Elm architecture, we've got the view side and the update side. The update, again, straight out of the tutorial, is a function that takes the message that we've defined and a model and produces a new model. So the message is going to be either increment or decrement, and the model will be the integer that was defined. And when you increment, it simply produces a number 1 higher or decrement 1 lower. So now the Elm architecture can go a step further. The one we saw before was someone insultingly called beginner program. The next step up introduces those messages from other places. So at the basic level, you can have messages from users interacting with HTML. At the next level up, you can have them in commands that come from the program, from the update itself, from the init to start the program, and from subscriptions, which are how you get input in from JavaScript. So these command messages can trigger activity and interaction with the outside world if you want to do that sort of thing. And here, beginner program becomes program. It's a little more complex. The update signature has grown. Subscriptions are how we get input from the platform. This is the user hitting the keyboard, browser changes, like window resizing and that sort of thing, or interaction with the outside world, websites. And these subscriptions are defined again as a function, because everything's a function. And you'll notice that the model is passed in as an argument for this function, but it is not used anywhere inside. Now, Elm, I'm going to take this opportunity to highlight one detail of Elm, that the runtime does a lot of things for you to make it more efficient. And one of those is capturing and memoizing function results. So, although this function is defined and could theoretically be rerun every time the cycle works, it does not, and the Elm runtime catches it and only does this once. So Elm's got your back there. Commands are how we make requests to the platform. So Elm is a purely functional language, so it can't do things like store data. It can't generate a random number, because a function that generates a random number would not be a function that always produces the same results, unless you want the same random number every time. So it uses these commands to go out to the runtime and get the results back as messages from the system. So those, and finally, the third level of program is to introduce flags that can come in when you first invoke Elm from JavaScript. Now, I've shown you probably far too much detail of Elm functions for how the view and the model and stuff work to make it appealing. So I'm going to say that Elm really is pleasant to work with, and the compiler is why. The compiler does very nice things for you. I've worked with systems that say they're opinionated, and yes, they are. But the Elm opinions are expressed in a meaningful way, instead of simply not understanding what you want. Elm tries its best to tell you what's wrong. So I'm now introducing Ellie. This is an online Elm development environment, and it's very nice. Here is an Elm program in the wild, well, almost wild. You've got HTML, you've got Elm that gets invoked from inside a script, and then this Elm text above is what's actually being invoked. And Ellie was put together by the community. It's handy. You can load packages and expand your system quite a bit here. And this is Evan's architecture demo code with a problem. It cannot find the pattern decrement. And it helpfully, the compiler helpfully says, maybe you meant this. And sure enough, misspelling. And the problem was quickly found. It has other benefits. So here, the first and second branches of the case produce different types of values. Increment is producing model +1. Decrement is producing a string. and it spells that out for you. It says the types do not match. It gives you a hint on how you might improve it. So, and of course the fix is easy when you cause the error yourself. Where'd my talk go? I closed the wrong window, didn't I? I lost it. What's it? Huh. I'm supposed to shift. Folks on live streaming, pay no attention to this. That's. Shift down. Sorry about that. All caught up. And the last example from the compiler is the missing branch. It's very important in Elm that when you have a type like message, you have to cover all the cases. So you can't leave some part undealt with. Everything in there has to be handled. If you've got a message that has 14 different kinds of messages, then you have to cover all 14 cases. It can feel a little bit exhaustive at times, or exhausting, but it's a lot safer. So you've got to put that decrement in there. This leads to a pattern of work that I would call compiler-driven development. And I lost it again. I have this all beautifully set. All right. So if you did not have the stuff that I'm not supposed to have here yet, and you wanted to expand the operation of what you're doing, so you've got the normal operating program that we've seen, and you wanted to, say, extend and add in a new button that each time you clicked on it doubled the number. You could add the text in, add it into the model, and your new double message cannot find variable double. You would look and you'd say, oh, I'm doing on-click decrement and increment and double. I have to add that to my message. Oh, and again, the same case problem shows up. You have to account for every part of it. So the compiler leads you by the nose. It allows for much safer modifications because everything has to be handled. You can do refactorings that might otherwise be frightening. In addition to the compiler, there are a lot of packages that are out there, and they have a following of semantic versions. And they are well published, they are out on the web. There are published packages like this that you can search for. If you want something for math, you have to spell math correctly. If you want something for graphics, there's all kinds of packages out there. And as I mentioned, the semantic versioning, they have strong indicators of when something is not ready for the newest version, 0.18 being the current version of Elm. And there is also a functional search. So if you know you need to do something, but you don't know exactly what it is you need to do or what package it might be part of, you can do a search by the type signature. So if you've got a function that goes from A to B, and you've got a list of A's and you have a list of B's, you could define the type of the function you're looking for. You could search for that function and you could say, oh, you've defined map. That's pretty similar to concat map as well, or filter map. And then it takes you right over to the specific definition, and very helpful. And then you could add that package, and it would show up right there in your Elm package JSON definition with a strong type definition defining a semantically versioned package that you want to use in your code, and what version of Elm you're using as well. Now that semantic versioning is enforced, so when packages are published and you try to publish a package that has a breaking change, you have to upgrade that first number. Yes. It's worth clapping for. So if you don't do anything that changes any of the signatures, you can create a patch release. So that the Elm Lang core, and you can do this from the command line, run the Elm package diff, and it will tell you there is no semantic version difference here, it's just a patch version. If you run that same thing against a minor release where the second number is different, it says they've added a new function. Adding a function doesn't break previous functionality, so it's allowed to be a minor version because functions don't interact because they're pure. That's all good. And then finally, if you have a major release, say the difference between 1.0 and 2.1, it can list out everything that's changed. There's an added function. More importantly, though, it removed a function or changed a function. And that gets a little more complex, yes. So, semantic versioning is your friend, or at least my friend. Elm also has a time-traveling debugger, because you need that. So, here, let's see, counter you've seen. This evening was advertised that I would show you a little bit of a game. The game is not quite ready for prime time, but it is written in Elm, and it's a game of Checkpoint Danger, which was a discontinued 1970s Milton Bradley game that's halfway between Battleship and Sudoku. It's a lot of fun if you can ever find a game in a second person to play with. So here is the interaction of setting up your agents on your side of the world, and I'm providing counts of visibility to help you think about where you set them up. And then one might explore the history of the actions in the game. So you saw that I clicked on a few things, and it has a tracking of everything that went into. So there's the full state of the model of the game all the way along. And you can export that to a file, and someone else could load that in and reproduce exactly the same state of the world somewhere else. So what bugs you do manage to create are easily reproduced. And when you're done, you can yeah. And I live in Edgewood, and I am not on Elm Street, but I'm only a few blocks away. So there's a picture of it. And we decided to do questions both times. So
you showed the incompatible with current version status on the index of current packages. is there history of the package index without that function that you can say how much that may have helped with encouraging the package maintainers to actually be prompt in supporting new versions?
Yes, there has been occasionally folks that have come into the community and created packages and left them fallow, but not many. It's been a very engaged community, but it's very young, so we'll see.
It's more like, was that act of making the index show the out-of-date things instrumental in encouraging that pattern of behavior that the community has now?
It certainly seems that way. It's the rare thing that I find that I want that isn't up to date. And if you're on the Elm Slack, which if you're going to do any Elm, I recommend you get on. They're very helpful and burn through their message queue very quickly. But they have had one package that seemed important that got neglected, and alternative came up quickly and people updated it. Also, for the updating, they have been very good about providing support code that will analyze your 0.17 Elm code and suggest how it should become a 0.18, even to the point of doing some of it.
Tying into that, if there's no one else with any questions. In order to replace a package, it seems likely that you'd want to have a manageable signature of the exported functions, and nothing you showed went into visibility of symbols or the like. Does it tend to be the case that the symbols exported are relatively minimal, so someone could reproduce the interface to an abandoned package, or is it that you need to support the entire method of how it was implemented before? I'm not making that very clear.
Yeah, so here's that's a core package, so it's going to be a little richer than some, but it has the functions and it might have the definitions of some of the types that those functions operate on. So if you were to produce another function that's drop-in compatible, you would need to match a lot of the types. There were replacement packages for, I think, one of the collections, a RAID, something that someone developed and said, this is faster. And they matched the types and matched the function signatures, but their types, the function signatures were identical up to the point of models. Their models were distinct so that they could be used side by side. Is that sort of where you're talking? It's functions on types. That's the whole of the.
I'm kind of thinking about opacity of types, perhaps, so that the implementation details don't need to necessarily be visible to the person using the package.
Yeah, so I glossed over it. There's two ways to define a type in Elm. You can define it directly, and you can define it as an alias. And there has been some effort to use those in combination to make for more opaque types, so that they can offer signatures that are that only expose aspects. But I cannot speak too deeply on that. Yes.
How are the messages that the compiler sends when you upgraded to like a newer version of Elm, to like if you have a breaking change in your code? Right.
So if you're making a breaking change, the issue
so
comes
like,
up.
you know, you're using an old syntax that's no longer supported.
Yeah.
Does it actually tell you like, hey, this is not supported and you should change it to this? Or
So I've seen upgrades from 16 to 17 and 17 to 18.
mm-hmm.
And there were Elm packages released that you could aim at your older code. So it's not the compiler as such that can take older code and recognize it and change it. It's a specific package for that upgrade. And they were pretty good with their messages as well, taking the cue from the compiler. But yes, so yeah, the upgrade is not intrinsic to the compiler.
Okay.
But the messages were pretty much as helpful, and it actually did some changes directly to the code. So it processed the code and produced mostly compatible new code with suggestions about, over here you need to do something else, but we're not sure what.
Oh, nice.
So yeah, the upgrade code is on GitHub for the last two. And I think some people, I think they've been forked a few times and improved further.
So it's not too much of a challenge to upgrade from one version to another usually, or
No.
that's bonus.
Yeah, I was just beginning and feeling comfortable enough that I was ready to apply the code to a published library, offer it up as a PR, and by the time I pulled it all together, someone else had already done that. So it was a very quick response in the community to the migration. All right. Well, now we get to hear about Elm and React.
Thank you.
Sorry, go song and dance first.
All right, so this presentation, you can actually look at it on GitHub, follow along and such if you want, or review it after the fact. But I'm going to be going over kind of approaching Elm and Elm single-page application development, coming from having previously done some React and Redux work. I'm going to be talking a lot about the Elm architecture specifically, not so much about the Elm language. The Elm architecture, of course, being those HTML.program and HTML.beginner program that take the model and the initial function and the update function and put them all together into something that actually, works on a web page. So let's see. We're going to be going over concepts that are familiar to both Redux and Elm, and then I'm going to be giving kind of generalized definitions that apply to each one of them. So, for example, the store. A generalized definition that shares between both Redux and Elm, and a lot of these are going to share a lot because Redux was based off of Elm. A store is something, it just keeps the state of the application. So this state can be read and transformed, but in Redux and Elm, you really don't want to actually transform. Well, in Elm, you can't actually transform a state because they're all immutable data types. And in Redux, you really don't want to because it's going to break your app. So React Redux, in React Redux, the store comes from the default store parameter in the reducer or reducers. You see a lot this pattern where you say the store equals and then the default state, or the state equals the default state in your reducer, which is using a nice ES6 convention where you can add a default parameter. And so a lot of times this is how people kind of initialize their state. But if we're using multiple reducers, the shape of the state comes from the structure of the input map that you give to combined reducers. In Elm, however, the structure is defined by the model type. Now, model is not like a special word. It's just whatever the type signature is that you've given to the thing that you're going to call your state. It's initialized by the init function, which you give to beginner program or program, and it's transformed by the update function, which is kind of what we would call reducers and redux. The type definition for the model is not passed to the program at all. It's just defined as whatever init returns and whatever update takes in as one of its parameters. So next we're going to talk about the reducer. The common definition here is the reducer transforms the store in response to an action. And again, in Elm you can't transform a store, and in Redux you really don't want to actually change the store. You want to return a new state. So in React Redux, these reducers take the form of functions which take in the current store and an action, and then return the transformed store. Usually there's a switch statement in there, which is dependent on which action was passed in. In Elm, this is very similar. It takes in the current store and a message, and then it returns a tuple containing the new store and a command. And commands are how we produce side effects, which I'm going to go into next. So for React Redux, it doesn't have any built-in ability to deal with side effects while still keeping its reducers pure like Elm does. We have to use a third-party library, which I'm about to get into, whereas Elm comes with the ability to just return commands. So side effects we're defining as anything outside of a pure function. A pure function is defined as it always evaluates the same result when given the same argument values, and it causes no side effects, such as mutation or input and output. Programs usually have to have side effects. A program isn't much use if it doesn't, write a file or connect with some kind of server, and these are all inherently side effects. The goal is not to not have side effects, but to isolate any side effect producing code as much as possible. In React Redux, the common pattern is to use the func middleware and dispatch a function instead of an object when you use the dispatch function. So normally you'd be dispatching an action object, but when you use the func middleware, you can dispatch a function instead. This keeps your reducer pure, and it moves the side effect creation code into the func function. However, it's still up to the developer to keep side effect producing code out of their reducer, moving it to the func. You can accidentally include it in your reducer still. In Elm, however, you literally cannot put side effect producing code in your reducer. All side effects have to be handled with commands. So commands are used to do such things as Ajax and generating random numbers. As was talked about just a minute ago, generating a random number is not the kind of thing a pure function does unless you're giving it a seed value. But then it's not very random still. So commands are given a message type as an argument, which they can call the update function with. So for example, in JavaScript we often use promises, and the result of the promise is given to the function that you pass in with the .then function. And that function is used to retrieve the result of like an AJAX request. However, in Elm, you would give to the AJAX kind of performing command a message type, one of those message types that are given to update. And when the AJAX comes back with a response, it's going to call the update function with that extra bit of data, the response, already attached to the message type, which the reducer, basically the update function, is going to be able to extract out of that message type. So, components in React and in Elm can be described as some kind of abstract structure which is used to create HTML. In React, we don't write just pure HTML, and neither do we in Elm. So in React Redux, components can either be functional or React classes. People are talking a lot about writing purely functional components, and that's getting a lot closer to Elm than it was when you used React.createClass, I think. There's JSX formatting. It looks like you're writing HTML directly in the JavaScript file, but this is all a transpilation issue. Specifically, the app must be connected to the store using the provider component. When using the React Redux library, there's a component called provider. And through using the provider component and using the connect function, that's how people usually connect their components to the store so that they can dispatch actions back to the store from a nested component. In Elm, though, all components are functional, and components are basically functions that have to return an HTML with an HTML type with a subtype message. There's no JSX formatting. It uses only functions imported from the HTML library and attributes imported from HTML.attributes. So the view function, which is given to the HTML.program and HTML.beginnerprogram functions, that view function is given the model when it's called by the program, which then you can pass that model to any of your other component functions. It's up to you to pass that model down. The view function ultimately returns an HTML with a message subtype. When a message is produced, it automatically gets sent to the update function. You don't have to call connect or any of that kind of thing. It just gets produced. Messages are produced through the onStar attributes of an HTML element, imported from the HTML.events library. And onStar is anything on click, on input, on change. These all will throw off the messages that you give them, as shown in the previous code samples. So, external events, we're defining pretty specifically here as events which originate outside of the app with no initiation from the app. We're talking here WebSockets, not AJAX. AJAX is initiated by the code itself. You send a request and you expect a response back. For example, with WebSockets, though, you can receive a response and have never requested anything. And that's kind of the difference between what I'm defining as an external event and what we defined earlier as a command or as a side effect. In React Redux, what's suggested is to handle these kinds of things with middleware, which is like a slightly advanced concept in React Redux. Middleware is just a function that can dispatch actions based on events outside of React Redux. For example, you get a WebSocket mission, and then you dispatch a special type of action which contains the content of it. In Elm, however, we have, specifically not with the beginner program, but with the HTML.program, we have subscriptions. And each subscription is registered with a message type. When data comes in through that subscription, it's attached to the message type given and then sent straight to the update function. You tell it what you want to subscribe to, and then you give it one of your message types, and it gives you back whatever data it gets. So for example, if you wanted to subscribe to WebSocket emits, or you wanted to subscribe to ticks of the millisecond clock specifically, you can subscribe to either one of those. They're both externally initiated by, you know, the system clock or by your WebSocket server. So in the previous examples we saw, those were all single page apps, but they were all within a single file. How do you break up a complex app? Sometimes they get too big to put into one file, and you do it in different ways, but pretty similar between React Redux and Elm. In React Redux, most of the time you take your separate reducers and you put them in separate files, but then you import them all into one file and you give them to the combine reducers function in a map, which then defines the shape of your state. The functionality of each of these reducers is separated by the key of the store, which it's given to combine reducers in. In Elm, there's a little bit more work. It's very similar to React Redux, but it's split up as thus. Each section of the functionality would have its own custom message type, model type, and update function, which it would all export. The main Elm file, where you put everything together and give it to html.program, would import all of these message types, models, and update functions. The custom message types would be unioned together into a master message type using the pipe character. That same pipe character we saw that separated increment and decrement earlier. The custom models are combined into the main model using a map with keys, for instance, but I guess you could use an array too. The custom update functions would be called in the main update function, using a case that would separate each of the update functions out based on those previously separate message types that were all unioned together. Well, you can split those up again and then pass the action to, or pass that message and the state to each individual update function that was exported from its functionality, or from those previous function files. So Redux kind of combines the steps of the shape of the state and the combined update function. It kind of combines those two steps together in the combine reducers. And as you see here, you have to do those separately when you split an app up in Elm. Now, you may be wondering, do I have to rewrite all of the nice libraries I'm used to, like HMAC or any other complex library? You can do JavaScript interoperation, and it's remarkably similar to sending and receiving messages to a WebSocket. Ports are created in the Elm app and receive data from JavaScript outside of the app. The flags were discussed earlier, and those are for init time configuration, such as giving the app a key to identify a user, for example. So commands are created and then sent to the ports that you've signified, just like you would send a command to the WebSocket to emit some data to the server. You subscribe on those other receiving ports to allow new data to come in, the same way that you subscribe to WebSocket to receive data from the server. The JavaScript has to be connected to those ports outside of the Elm app, usually in the script tag in the HTML file. The data is sanitized when coming into Elm. You've got to define the incoming types as maybes, I think, and then these are all going to either produce no result or produce the result with the correct type of whatever you've defined. So you never have to worry about a string coming in when you wanted an integer, for example. And now we've come to the end. Does anyone have any questions? Nope. Oh.
Do you have any example which could help visualize this?
No, I don't actually. Not on my computer right now. Yeah.
Thank you.
All right. Thank you.